episode 2 of the Python tutorial. Today, we're going to cover collections, console I/O, and ways to manipulate how the computer reads your code, as well as when. Let's first talk about collections. Collections are a way to group data together. And in Python, there are two simple types of collection. We have tuples and we have lists. Tuples are typically used for associating different things with one another and are specified using parentheses, like so. This is a tuple, and you can assign it to a variable. As an example, here's another tuple, this time with an integer, a floating point number, and a boolean. By the way, we call floating point numbers floats for short. As you can see, tuples can hold many different data types inside of them. Lists are typically used for collecting many of the same kind of thing, and are specified using square brackets. So here's a list. We can even add a string onto the end here. And at this point, you might be wondering, what's even the difference between tuples and lists? As you can see, they both hold many different data types inside of them, and they're both of arbitrary length. Well, the difference is, once you've created a tuple, you cannot resize it. However, with lists, you can. We'll go over the specifics of how to do that later, but just know for now that that's the difference. The print function, as you might remember, prints text to the console. That's why it's called print. Well, there's another handy function that Python gives us for interacting with the console, and its name is input. The input function reads text from the console and then returns it. Remember that for a function to return something means that it evaluates to that value. So we can assign that value to a variable. We can say, for example, my user input equals input, and then you can give it a prompt. This prompt will be printed before the user is asked for input. So you can maybe put a right arrow like this, and that will look like a prompt. With this function, we can set variables based on what the user of our program decides to type, without them having to read our code at all. We can print out its value to verify that this is working as we expect. As you can see, we received the prompt of arrow followed by space, and then we typed hello. When we typed hello, it printed hello back to us, then it printed true because it was equal to hello. When it comes to reading other data types such as int and float, we'll go over how to do that later. That's about it for input. It's a pretty simple function and pretty easy to understand. On another note, there's often a reason that you want a piece of code to only run sometimes. In programming, this is called a conditional block. And by the way, a block of code just refers to a sequence of instructions that are grouped together in some way. For example, this group of 3 lines could be considered a block, if you want to define it that way. Or you could say that these 5 are a block, including the empty line, I suppose. In Python, we can explicitly specify blocks, but we require a certain kind of statement that is special. A conditional statement is one such construct. For example, we can say if true, colon, and then follow it up with an indented block, which means that it's a block that we add spaces on the left-hand side. As you can see, whenever we did if true in PyCharm, it automatically indented the following code for us. That's a sign that we're doing the right thing. Whenever you're done with the block, just press backspace and it will erase the indentation. Now, if we modify the conditional, this will still always print, but these will never print. Let's run it to verify that this is working as we expect. True is true. This will also print. This will always print. Optionally in Python, you can also provide a second block to the conditional statement. This second block will run whenever the condition is not true, in other words, when it's false. And the way we specify this is with the keyword else. Of course, this line of code will actually never print. Whenever we run it, we will see that that is true. You can see that there's nothing in between these two lines. And PyCharm even gives us a warning saying that this code is unreachable. Of course, in a real program, the condition would be more complicated than true, so you wouldn't see that warning. Finally, there's a way to chain these conditional expressions. What chaining means is that it will check multiple conditions and execute the first block whose condition is true. And if all of the conditions are false, then it will go for the else block. So we can add in the middle here, elif, which is short for else if. So let's change the first condition to be false. And now we will see true was true as the only line of output besides this one. Here you can see that in action. So the conditional statement is not only useful for conditionally executing code, but for selecting among multiple blocks of code based on some set of conditions. Combining these powerful conditional statements with the input functions can lead to a program that appears to respond to the user. With this, you can make your first interactive program, but it's not extremely interesting yet. Let's try it. We'll delete some code here. We'll say response equals input, enter hello or goodbye. Now we can do the conditional statement. If response equals hello, else if response is goodbye, and in all other cases, print something sad. Don't you feel bad for the computer now? Anyway, that's about all I have to say about conditionals. By the way, you can just call them if statements for short. They're very useful, and I recommend you go out of your way to find places that they fit in your code. There are still more ways to alter what parts of your code the computer reads and when. Frequently you'll find that you want to repeat a certain block of code until the program state is the way that you want it. Remember that program state is represented by variables. What that means is you want the block to repeat while some condition is true. Luckily, Python has a construct for exactly that purpose, and it's called the while loop, otherwise known as the while statement. While loops are useful because they prevent you from having to copy-paste code that you don't want to copy-paste, or for allowing you to run code indefinitely. The syntax is similar to that of a conditional statement. It's the keyword while, followed by some condition, followed by a block. And if we run this code now, we will actually hit an infinite loop. And you can see that PyCharm is struggling to keep up with the program now, because it is printing infinitely. You can see that we're at 41,000 lines of output. Just hit the red square to stop it. Keep in mind that if you're not careful, and this condition is more complex, you can accidentally end up with an infinite loop like the one that we have here. Always be on the lookout for those. There are also frequently cases where you want to go over each element in some collection, for example a list. For those, we have something called the for loop, or more accurately, the for each loop. So let's create a collection, and then iterate over it. Just like that. As you can see, PyCharm is warning us because I forgot to delete the infinite loop here, so this code is unreachable. Here you can see that we printed 1, 2, 3, 4, then 5, which is exactly the order that we specified them in the list. And finally, there are times when you want to repeat some code some finite number of times. You don't necessarily know how many times, so maybe it's set to a variable. I'll call this variable num iterations. For this, we have the range function. It takes two arguments, a minimum value and a maximum value. It will go from the minimum value up until one less than the maximum value. It will never hit the actual maximum value. Keep that in mind. It's very, very important. So this will iterate from 0 to 9. Let's actually use the variable that we specified. And we will see 0 through 9 in the output. There we are. That about covers it for episode 2 of the Python tutorial. I hope everything was explained well enough. I'll see you in episode 3 when we cover functions.